If you've ever had to work with data in Java, you know the deal. It's not just what you store, it's how you store it. Get that wrong, and your whole application can just grind to a halt. So today, we're going to pop the hood on Java's master toolkit for data, the collections framework. Let's see what's inside.
And that's a totally fair question, right? It's one every programmer asks when they're starting out. I mean, arrays are simple, they're fast, and they're usually the first thing we learn, so why bother with anything else? Well, the truth is, the second your application starts to get even a little bit complex, you're going to smash right into some very hard limits.
And here they are. First off, arrays have a fixed size. Once you say an array holds 10 items, that's it. It's always 10 items. So what happens when you need an 11th? You have to make a whole new, bigger array and copy everything over. Not great. Plus, there's no easy way to just yank an element out of the middle or add a new one without you manually shifting everything around. It just gets messy fast.
So to solve all these headaches, Java gives us the collections framework. You should really think of it as a master toolkit. It gives you a whole set of highly optimized, ready-to-go data structures that handle all that messy resizing, inserting, and deleting for you. It's basically a unified system for managing groups of objects, and honestly, it's absolutely essential for writing clean, efficient code.
So for our tour today, we're going to hit the 4 core parts of this framework. We'll kick things off with the super versatile list. Then we'll explore the unique world of sets. After that, we'll see how queues keep everything in line, and finally, we'll unlock the power of maps. By the end of this, you'll know exactly which tool to grab for pretty much any data job you have. Let's jump in.
First up, lists. You know, the best way to think about a list is to picture a bookshelf. You put books on it in a specific order, right? And you can totally have 2 copies of the same book. And you can always find a book just by knowing its position on the shelf. That's a list.
And that's pretty much what the list interface guarantees. It's an ordered collection, which just means it remembers the order you put things in. It's totally fine with duplicate elements, and you can grab any element instantly if you know its numerical index. Kind of like an array, but way more flexible because it can grow and shrink.
Now, the list interface is just the blueprint. The 2 big implementations you'll use are ArrayList and LinkedList. And picking the right one is super important for performance. See, ArrayList is backed by a good old array, so it's lightning fast if you're mostly just reading data from specific spots. But if you try to add or remove something from the middle, oof, it has to shift everything that comes after it, and that can be slow. LinkedList, on the other hand, is made of these nodes that just point to each other. It excels here. It can add or remove elements from anywhere, instantly. So here's the rule of thumb. Doing a lot of lookups by index, use ArrayList. Doing a lot of adding and removing in the middle, LinkedList is your best friend.
All right, let's move on to our next stop, sets. So if a list is like that ordered bookshelf, a set is more like a bag of marbles, where every single marble is unique. You just can't have 2 identical marbles in the same bag.
And that's the one single defining rule of a set. It's a collection that enforces uniqueness. It simply will not allow you to add a duplicate element. That's its superpower. So if you ever need to store a group of items and you have to be absolutely sure there are no duplicates, a set is the tool you reach for.
Let's see how this actually works. So imagine we have an empty set. We call the add method with the string apple. The set looks inside, sees it doesn't have an apple yet, so it adds it in, and the method returns true. Success. Simple enough.
Okay, but what happens if we try to add apple a second time? Well, the set checks its contents again, finds that apple is already in there, and it just rejects the new one. The collection doesn't change at all, and the add method returns false. This little example shows you the core promise of a set perfectly. Uniqueness is guaranteed.
And just like with lists, you've got options. If all you care about is pure speed and the order of things doesn't matter at all, hash set is your go-to. It's the workhorse. But what if you need to remember the order you added items in? Like for a music playlist, that's what linked hash set is for. And if you need your unique items to always be sorted, say you have a list of usernames you want to display alphabetically, well then you grab a tree set. It's all about matching the tool to what you need to do with the order.
Our third stop is the queue, and this one is super intuitive. A queue is just a line. That's it. It's just like the line you stand in a grocery store or a coffee shop. The first person who gets in line is the first person who gets served.
And that's exactly what the queue interface is built for. It holds a bunch of objects that are just waiting to be processed, and by default, it follows that strict first-in, first-out order, which you'll often see called FIFO. Whatever you put in first is the first thing you'll get back out.
And here's a perfect real-world example. Imagine you have to send out a text message blast to like 100,000 people. You can just add all those phone numbers to a queue. The system will then pull the numbers from the front of the queue one by one to send the message. This makes sure that the very first number you added is the very first one to get that text. It's a really fair and orderly way to handle tasks.
Okay, our final stop on the tour, maps. Now, if all the other collections are about storing individual items, a map is different. It's all about storing connections between items. The best analogy is a dictionary. You have a word, that's the key, and you have its definition, that's the value.
So in a map, you store your data in pairs. Each pair has a unique key that you use to look up its value. For instance, the key could be a user's ID number, and the value could be their entire user profile object. And the keys have to be unique. You can't have two entries for the same user ID, but you could have multiple users with the same name, so the values can definitely be duplicated.
And you guessed it, which implementation you choose all comes down to what you need from the ordering. HashMap is the fastest for just general-purpose storing and retrieving, like for caching user settings. If you need to loop through your entries in the exact order you put them in, linked HashMap is your choice. And TreeMap is awesome when you need your keys to always be sorted, perfect for something like a phone book where you want all the names listed alphabetically.
Okay, we've covered the 4 major types of collections. Now for the most important part. Let's put it all together so you can confidently pick the right tool for any job that comes your way.
So let's bring it all home with this simple guide. Just think back to our analogies. When you need a simple, ordered sequence that can have duplicates, you grab a list. That's your dynamic bookshelf. When uniqueness is the most important thing, you need a set, your bag of one-of-a-kind marbles. For processing tasks in a fair, first-come, first-served way, it's always going to be a queue. And finally, whenever you need to link one piece of data to another for a quick lookup, you'll reach for a map, your own personal dictionary.
So there you have it. Lists, sets, queues, and maps. These are the fundamental building blocks for just about any data handling you'll do in a modern Java application. And really, understanding which one to use and when is a huge part of being a great developer. You've got the toolkit now. The only question left is, what are you going to build with it?